Hello, my name is Christina Boardman, and I'm here today to talk to you about electroencephalogram, or EEG correlates of criterion placement in a security patrol paradigm.
The criterion is a measurement in signal detection theory, which models how a detector distinguishes between targets and non-targets relative to evidence of a critical dimension. In cognitive neuroscience, we use this theory to model human decision-making. For example, in a facial recognition task, we ask participants to study and remember face images, and then to distinguish studied or old faces from unstudied or new faces. In this case, we are asking participants to judge images according to their familiarity. Possible response types include hits or correctly remembered studied images, misses or misstudied images, correct rejections of unstudied images, or false alarms, unstudied images incorrectly identified as studied. Discriminability describes how well you can distinguish between targets and non-targets. The criterion is how much evidence you need to identify something as a target. Criterion shifting is when you vary your criterion placement according to your situation. For example, when doing a general security sweep, such as a TSA bag check, a security officer may want to use a liberal criterion, requiring less evidence to avoid missing information about a potential threat. However, when trying to apprehend an individual, a security officer may anticipate the use of force and want to use a conservative criterion to reduce the risk of harming an innocent person. This fMRI contrast from Amanoff et al. Shows a difference in deoxyhemoglobin activity between two conditions, or differential activity. You'll notice the H greater than CR on either side of the label. This indicates contrast for hits minus correct rejections for conservative and liberal criterions. These were then contrasted with each other, so what we're looking at here is a contrast of contrast. A conservative criterion placement requires more familiarity for a hit, so the analysis was performed this way in part to show the effects from criterion differences and not from familiarity. The take-home here is that there is differential activity for conservative versus liberal criterion placement in dorsal and medial frontal areas and posterior dorsal parietal area.
Here we expand on Amanoff et al. By exploring EEG correlates of criterion placement in a security patrol paradigm in individuals who adequately shift between liberal and conservative criteria. We predicted that maintaining a conservative versus liberal criterion would be associated with P3, a large ERP peak occurring 300 to 600 milliseconds after stimulus onset. We are also interested in individual differences, and EEG oscillations are more reliable at the individual level than ERPs. So we also examined event-related spectral perturbations, or event-related oscillations over time.
For the behavioral paradigm, participants were asked to memorize face images of suspects and identify the suspects in a testing phase. To manipulate their criterion, we told them that identified suspects would be questioned for the liberal placement or hunted down like criminals for the conservative placement. We also manipulated discriminability. For moderate discriminability, participants were shown an image 6 times during the study phase. For low discriminability, participants were shown an image only once. This ERP graph shows H greater than CR ERP difference curves for conservative and liberal criteria in the low condition. In a one-way single-channel ANOVA, we compared H greater than CR activity between conservative and liberal trials. We found that maintaining a conservative versus liberal criterion was associated with a significant increase in relative P3 power in frontal electrodes AFC and FC. We also found a significant increase in the P3 associated late positive potential for these frontal electrodes. With an R squared of 0.2, the association between the late positive potential power in AFZ and the criterion placement had the largest effect size out of all our channels and ERP peaks. For the moderate condition, we found a modest effect in posterior electrodes and no effects in frontal electrodes. Since the conservative condition requires more familiarity for hits, we would expect some conservative greater than a liberal activity to be memory related. We'd expect these effects to be stronger in the moderate D' condition, since the higher discriminability indicates higher memory strength. The fact that we do not see significant frontal P3 activity in the moderate condition indicates that the differential activity we observed in the low condition may be more related to criterion placement than memory. In our ERSP analysis, we broke this EEG signal down into frequencies from 0 to 30 Hz using a Morlet wavelet analysis. Our ERSP results were mixed. We had hoped to see a significant effect for maintaining a conservative versus liberal criterion in P3 associated lower frequencies, delta and theta. However, our bootstrapping analysis indicated that most of the significant differences showed a decrease in power for conservative versus the liberal criterion. The one exception was the theta band in the mid-central region, but it occurred well after the P3 time frame. Additionally, it was for the moderate condition, not the low condition, where we observed our largest ERP effects.
In summary, as predicted, maintaining a conservative versus liberal criterion was associated with P3. The effect was significant for the low discriminability condition, but not for the moderate, which indicates the effect is primarily due to criterion placement and not memory. However, the effect size was modest, and we observed large participant variability. Our next step is to conduct an event-related spectral perturbation analysis for individual differences. In the long run, we hope that criterion-associated EEG signal could be used by military or police organizations in personnel training or assignments.